right, ladies and gentlemen, welcome back for another round. This is Mr. Doolin, and I thank you so much for tuning in. Today what we're going to do is we're going to take a look and run through the pre-lab for our density of metals lab that we have coming up. The purpose of this lab is to take a sample of irregularly shaped metal pieces and use density to ID the metal from a list of possibilities. So let's run through a couple of things that we need to know. First off, we need to remember what density actually is. Remember, density is a ratio of mass over volume. And so if we were going to determine the density of this particular metal, you have to understand that we are going to have to measure both mass and volume. If you recall from our previous lecture, I think lecture 1.1, we go over our mass, we're probably going to end up measuring in grams, and our volume based on these SI units, we're going to be measuring in milliliter as the glasswares that we're, or the pieces of equipment that we're going to have to be available for us. The one thing I want you to understand about density, and we're going to go ahead and kind of let the cat out of the bag as well, is that the density of a substance does not change. And this is really important conceptually for you to understand why the lab and how the lab is set up the way that it is, because we're going to be taking these samples and break them into smaller sets and then combine them all together at the end. And it's the understanding that it doesn't matter how big my sample of metal is, those pieces have the same density as all the other pieces in your sample, because the density of a substance does not change. And I need you to understand that, right? And so it doesn't matter how much we have, that mass and that volume will change proportionally to keep this ratio of density for that particular substance constant. Now for equipment that we're going to use, I need you to understand for mass, we're going to be using electronic balance. And for volume, in this particular case, we're actually going to be using graduated cylinders today. So the first piece of equipment that we're going to use, and probably you'll use first, is an electronic balance. And I want you to understand a couple of things and how to use the electronic balance. The first thing is all electronic balances have this tare function, or it's called zeroing out or tearing something. And I need you to understand what we use tearing for. Let's say, for example, I were to take a cup and I'm going to put a cup on this balance, right? And I don't want to actually measure the cup, I just want to measure what I put into the cup. So what we would do is we'd actually place the cup onto the balance and we would hit tear. And so what tear does is it tells the balance to actually ignore the mass of whatever we teared out. And so this balance that I have drawn here really poorly would be, you'd understand that since I have a reading of 0.0 here, you'd understand I probably teared that particular cup out. So I set it on there, hit the tear button, everything should reset back to 0. And so that's something that actually is discussed in the lab procedure that you'll want to do in the lab today. The second thing is that we're actually going to have 3 different cups in our lab today, right? And I need you to understand that in this particular case, we're going to have a cumulative mass going on. So if these cups are labeled number 1, number 2, and number 3, if I were to take some of my sample of metal and actually put a sample of metal into cup 1, then my first mass in this particular case, because I would tear out all 3 cups, my first mass would be just the mass of metal 1, or the metal in cup 1. And then if I went ahead and put another sample of metal into cup 2, notice I'm leaving cup 1 on there with cup 2. So the second mass that I'll actually record is going to be a total mass of whatever the metal is in cup 1 and the mass and metal of cup 2. And then if I went ahead and put the metal into cup 3, you'd have to understand that my third and final mass that I would take in this particular lab would be the total mass of all the metal that was on the balance at that point in time. So it'd be cup 1, cup 2, and cup 3. And then another just quick little reminder, ladies and gents, remember this is going to be an electronic balance that you're going to be using in the lab, and we don't really have to worry about increments too much with electronic equipment. We just have to make sure that when we're recording our measurements, in order to keep that precision and that confidence level very high, we need to record all the digits that are shown on the screen for our electronic balance. So the next piece of equipment that we're going to use in the lab today, ladies and gents, is a graduated cylinder. And we've already seen in lectures how to read increments and how to use those increments to record the proper number of digits. But the technique that we're going to use the graduated cylinder for today is actually called water displacement. So water displacement is when we're going to put items into water and use the difference in like a before and after volume to determine the volume of the item itself. And so what you'll see over here on this left-hand area now, I've actually got a depiction of this. So notice our before volume over here is actually 500. And we'll see the increments here, and I'm just going to go, it's exactly 500 here. So our before is 500 milliliters. And what we're going to do is that in this particular case, we know the volume of the ball, but pretend that we didn't, right? We don't know what that volume is, but what we do is we put the volume into, or put the ball into the graduated cylinder, and notice my water level is not at 500 anymore. Now it's at 800, right? So my volume here, my after volume would be 800. So if this is my volume 1 and this is my volume 2, then you have to understand, right? Difference tells us to subtract. So volume 2 minus volume 1 would equal the volume of the ball if we actually didn't know what it was to start with. Now my question for you here now at this point, ladies and gents, is if I put a second ball into the graduated cylinder, could I figure out its volume? So if I had another ball right here, right, we've got this ball. If I take this ball and put it in there, it's definitely not 300 milliliters, right? And let's say that the volume went from 800 up to 1,000, right? We'll say volume 3 is equal to 1,000 milliliters, right? How would I actually figure out what the volume of ball 2 was? And we'll call this ball 2 up here, right? And this is going to be ball 1, so we would say volume of ball 1 over here. Now in this particular case, if I just wanted the volume of ball 2, I would do volume 3 minus volume 2, because now the volume 2 is the before I put ball 2 in, right? And this would give us the volume, only the volume of ball 2. Well, what if in a particular case I needed to know the volume, the total volume of both of them, right? I wanted to know the volume, so how would I figure out the volume of both balls, right? Cumulatively, and you understand I could actually do, right, in that particular case, this would be with no balls and this would be with both balls in there. So I do V3 minus V1, and that would give me the volume of both balls. And that's going to be important today because you're going to be pouring metal samples in, and we're going to want cumulative running total volumes of all the metal that's in that particular graduated cylinder. And so I really want to remind you too here, ladies and gents, with graduated cylinders, water displacement technique, we definitely want to avoid any blunders though, right? Remember that type of error that's a user error, and normally it's going to happen when we don't record the number of digits properly based on increments and precision. And so really make sure that we avoid blunders today and check your increments of your graduated cylinders before you get started. And the very last thing that we're going to do, ladies and gents, in this lab that's going to be another technique is we're actually going to use a physical separation technique. And it's nothing fancy, it's actually called straining. And so what we're going to do is we're going to have pellets of metal inside of water. And so what we'll do is we'll pour that sample into a strainer, and the pellets will actually get caught in that wire mesh of the strainer, and then the water will actually flow through, and then we can dry the metal off and it'll be ready for the next group. But I definitely want to give you just kind of a crude definition of what let me spell that correctly, of what straining actually does. And you need to understand, I'm not going to write it down here, but you probably want to write it down, is it will remove large solids from a liquid in this particular case. Now, there definitely is a more in-depth and technical definition of what straining actually is, but for today you can leave it as it's just going to be able to remove those pieces of metal from that liquid for us so that we can set the lab up for the next group coming after us, all right? And then the last thing, ladies and gents, safety and hazards for the lab. We're not really using any crazy chemicals. It's just metal. The metal is actually a non-toxic metal, so we run across it in everyday life. So your samples will be, you can touch them and feel them. Don't eat them. Definitely never eat anything in the lab because you don't know where that stuff has been. And then you are going to have to wear safety goggles because we'll be working with glassware and things like that. They'll be floating around the room. I don't want any pieces of glass get broken and poke you in the eye. So that should be it, ladies and gents. Hopefully that takes care of it, and you'll have a fun time doing the lab.